OS, or operating systems, manage how hardware and software run on your computer. At the end of the day, if there wasn't an operating system, no one would tell anyone what to do and nothing would work. So they allow for the management of internal and external hardware. So there you've got a network card that's being controlled by the operating system. Someone wants to access it, it allows it. How speakers get sound to them, it's controlling that. It provides an interface for users to be able to interact with the computer. So I know that there's a hard drive in my computer, but it shows me that visually as a graphical user interface. So when I'm storing a file, those little yellow folders don't actually exist on the hard drive, it's just a little symbol for me to click on. They provide a platform for different applications to run on. So Microsoft Word can't just run on its own. You can't play games without an operating system behind it. So it gives them a platform to play on or to run on. They allow the computer to multitask by controlling memory resources. So on the right is our memory. There's a valuable resource. Now who gets to use that memory is the job of the operating system. So if an email wants to use it, you want to use an email, it gets copied onto memory. You want to open a file up from your desktop, then it needs to go to memory. But not everyone can go to memory at the same time. So it deals with this resource management. The operating system is responsible for the file management and disk management. So when you save a file, we don't care where it goes. We just file save, and hopefully it comes back and we can load it again. That only is possible because of the operating system. The operating system decides where it's going to be stored. So we create a Word file. The operating system maps that into a sector that's written on the hard drive, and it knows where it is. As long as the operating system knows where it is, we aren't too bothered. But somebody has to be responsible for that. We often take for granted the fact that we can just use any device with our computer, but sometimes it doesn't actually go that smoothly. And in the old days, when you had a new piece of hardware like a printer or a scanner, you'd have to connect it up and install the software for the device drivers to make it work. Now, especially with Windows 7, when you plug in a device, Windows will automatically try and find the drivers for that software. Because let's take the Apple iPhone as an example. That's made by a completely different company to whoever may be making your laptop. So getting the two to work together isn't going to happen by magic. We need device drivers, and the operating system manages that. The other thing is that updates are released. So there might be a problem with the software. It might go out and it needs to be updated. That gets sorted out, and it all happens in the background. The other thing operating systems do is provide a user interface. So on the left is a command line interface where we're just typing in commands. On the right is a graphical user interface. This is where, let's say we want to open up Word, we click on the Word symbol. We want to go on the internet, we click on the internet symbol. The little graphics for graphical user interface, little pictures that we can click on, and it makes it really simple for us to use. And we almost become pre-programmed. Some people favour certain software over others because that's what they're used to. The command line is a little bit more trickier. So in the command line, usually we've just got text. But a command line is generally more powerful. So administrators tend to do things over the command line by typing in a certain command that will do certain things. Okay, so maybe update all the computers or change passwords or things like that. Whereas graphical user interface is designed so that anyone can use it. You wouldn't expect a young child to be able to use the command line interface unless there's some sort of like hacking genius. But a graphical user interface, like an iPad, you could give that to a small child and they know how to use it because it's more intuitive. Operating systems they're providing a platform for the applications to access the hardware. So we click the FaceTime app, the operating system, so iOS, whatever that is, allows you then access to the camera hardware. Because the camera hardware, that camera is in no way connected to the little icon of a camera there. It's the operating system that allows that. You click on iTunes and that allows music to come out of the hardware, the speakers on your phone. So it acts as a platform for applications to interact with hardware. So what we don't see is that only one application is being accessed by the CPU at one moment at a time. So the CPU can only deal with one application at a time. Now it appears, like lots of things are going on. So if you look at my taskbar, a lot of things are open and it appears like the computer's got all these things going on, but the actual CPU is only dealing with one at a time. So what the operating system does is it makes sure that the correct apps are being copied into memory. And also that if we think of memory as a load of boxes, if I've opened up Excel, well, I want that to be able to be used, so it gets copied into memory. I don't want to open up Word and then that go into the same memory box, so it's dealing with where applications are being stored in memory as well. File and disk management. Computer stored data as files and file extensions need to be opened. The OS is responsible for that file management. If you copy a file, the little symbol comes up and I've copied the file, there's another one appears. That just happens, but in actual what's going on behind the scenes is that sector has got to be copied across. When you delete something, that sector needs to be deleted and removed so that storage becomes free. There'd be no use in saying, right, well, I'm going to delete all these files, but you still can't write to there. Single versus multi-user OS. So there's different types of operating system. A single user is what we'd commonly use where we're using one computer and we interact with that one machine. So it's our personal machine. You might have different user accounts on it, but it's singly just one person's using it at one time. Okay, that's the idea. A multi-user is different. So a multi-user operating system might be, a good example is like a cache point. So those two cache points are both going onto the same operating system. You haven't got to take it in turns to get some cache out. Otherwise it would be pointless. If you want to go and get some cache or move something around, you can access online. So all those systems are working together because presumably a bank have a multi-user operating system. So more than one user can use the operating system at the same time. User accounts. Operating systems allow for user accounts. So traditionally you've got an account, maybe somebody else has got an account, and they can't access your files. They can't see what you're doing. Your files are your thing. So you set up a password for your account, somebody else can't get in. You're still using the same hardware, it's the same computer, but your turn, you have a go, somebody else comes in, they have a go. And the security features of that vary depending on what they're doing. Some phones now use thumb recognition to scan your fingerprint, so only allow you access to it.